Thank you. It's great to be here. I'm going to talk today about my team's journey replatforming and the important part that Mongo played in that. I'm going to show you guys our old stack, our new stack. I'm going to talk some about the indexing choices that we made. I'm going to talk about Atlas, which we use. I'm going to go over a few problems that we encountered with the new platform and how we chose to tackle them. And then we're going to have time for Q&A at the end. So stay awake for that.
Might be on.
Is it?
There's a switch on the side.
Of course there is. There we go. Who am I? Name's Ani Hammond. I'm a senior staff engineer and tech lead at BazaarVoice. Typical spoiled millennial. I don't like having to do things that I don't want to do. I like it when things are easy. So currently I'm very excited about serverless applications. I'm always excited about simple, intuitive products that have a clear mission. Now I know that it sounds like a stretch to call something like a database technology simple, but I think Mongo fits my definition perfectly because of how easy it is to develop with. And I'm going to hopefully make that more clear throughout the presentation. Software engineer at BazaarVoice. What is BazaarVoice? Our mission at BazaarVoice is to connect brands and retailers to consumers. What that means in non-marketing speak is that most of the user-generated content on brand and retailer sites is flowing through our network. By user-generated content, I mean ratings and reviews, Q&A, and social content. Here's a random selection of logos that marketing said I could show. But really, just to give you a better idea of our prevalence, if you're shopping online anywhere other than Amazon and you're reading a review, it's probably powered by us. To give you an idea of the scale that we deal with, here's some numbers from last year's Black Friday and Cyber Monday. On Black Friday, we had 530 million total page views on our network, which is about 6,000 per second. And on Cyber Monday, we had 470 million for a total of 1 billion page views in just those 2 days. What does a page view imply? Each one implies multiple API calls fanning out to dozens of our services. My team, Curations, built and manages some of those services. What is Curations? In short, Curations, the Curations platform allows a brand or a retailer to display relevant social content in the path of purchase on their e-commerce site. Let me walk you through the flow. Somebody posts a cute photo of their child wearing Gymboree rain boots on Instagram. Using Curations, Gymboree is watching for specific content that mentions their brand. The Curations social collection service picks up that post and shows it to Gymboree in the Curations application. Once inside Curations, a post can be enriched in various manual and automatic ways. By enriched, I mean product identified, moderation approved. It can be done manually by the client or through a set of automatic rules that define the client's needs. And an automatic rule would be something like take all content that has profanity in it and reject it. Once we have once the post is approved, the Curations platform reaches out on behalf of Gymboree to request permission from the author of the post to display their cute photo. So I don't know if you can make out the words here, but there's a comment from Gymboree saying, "We love your photo. Can we feature it?" And the person says, "Yes, please, thank you. We love Gymboree." Finally, now that we have the author's approval, the photo is shown in a Curations-powered display on Gymboree's site. I hope this all makes sense. 3 main things: we collect, we enrich, we display. How do we do this? All of our stuff lives in AWS. In our old platform, each client, so in the previous example, Gymboree, had their own cluster, which consisted of MySQL RDS volume, 1 or more EC2 instances running a Python Django stack, and a load balancer. So for roughly 400 Curations clients, we had 400 such clusters. Outside of these, we had a couple multi-tenant services, a social outreach service responsible for requesting author permissions, and a display service responsible for returning enriched content to all of our client sites. To meet display level scale, which we talked about earlier, we would ETL enriched content to a BazaarVoice-wide Cassandra ring before indexing it into Elasticsearch for efficient querying. Clearly, challenging stack to manage. There's a lot going on. Look at all the database technologies we're using. We have MySQL, we have Cassandra, we have Elasticsearch. And this isn't cheap. So this came out to $60,000 a month, and each additional client would add more and more money to that. Now, the $60,000 does not include the cost of all the booze that we had to drink to be able to deal with this nightmare. Why was it a nightmare? Maintainability, debugging any issue that a single client would submit, identifying the scope of bugs, patching, releasing even small patches through 400 systems, very challenging, managing data through 400 databases, very challenging. And the frustrating part was that most of our solutions were basically throw more hardware / money at the problem and have a designated DevOps person to manage these clusters, battle them when something went wrong, run Ansible scripts, whatever those are. Any system that relies on an ETL is obviously bound to have lag and for things to be out of sync sometimes. And then usability. Now, I know that Elasticsearch is awesome at what it does. I know a lot of people love it. It never really did it for me. I personally find the query language super verbose, super not intuitive. I'm sure a lot of that has to do with my lack of experience and expertise. But I will say I learned 10 times as much in half the time when I started using Mongo. So I think that speaks volumes of its ease of use. I'm not really even going to get into MySQL and relational databases. I'm sure there's like 5 talks going on right now about that. Don't run off to any of those, though. Mine's better. Knowing what we knew about MySQL and Elasticsearch, as we started talking about replatforming, we also started considering our options for what our next database should be. What were our considerations? So I mentioned the Curations platform does 3 main things. We collect, we enrich, we display. They each come with their own different access pattern. So you have collect, which is high writes. It's kind of more fault tolerant. We can always catch up with the social APIs. We have enrich, which is the complex rules I mentioned. They can be as complex as the client chooses to make them. So we often see things like, get us this content from Instagram from this geolocation that mentions #babyclothes. And send it all for human moderation. So high complexity. And then, of course, there's display, which is very high reads and 0 tolerance for outage or latency. So we had to have a database that supports all these access patterns. This one goes without saying, but we have to be able to scale as our client base and our content volume grows. Well, Curations is a relatively new product line, so we have a pretty substantial growth quarter over quarter in how much content we have. And finally, we have to be able to self-manage. So as we were starting to mention Mongo and discuss Mongo as an option, there was some pushback from our designated DevOps team at the time, just indicating that they're going to have a hard time supporting Mongo. They didn't believe it would scale. They really wanted us to go with Cassandra. And basically, they said, if you choose Mongo, you're on your own. So we had to be able to be our own DBA, but really we didn't want to worry about this at all, or we wanted to think about it as little as possible. At the time we started development, we still hadn't really fully set on a database. There were strong pushes for both Cassandra and Mongo. And in retrospect, I see that as a positive because it really allowed us to design a fully database agnostic platform, which I see that as a good thing. However, prototyping with Mongo is just very, very easy. It's easy to boot up a new cluster and or to boot up a new instance of Mongo locally and do anything you want with it. Before having our schema fully worked out, Mongo's schema flexibility allowed us to move quickly as needed. And exportability, obviously, it's very easy to, for somebody working on one piece to share data with somebody working on another piece. So exportability. We had the advantage of having early numbers to test with and kind of do our homework in terms of scaling. Because we were replatforming, we knew what kind of rules we were dealing with. We knew what kind of content we were dealing with. So we were able to do some solid testing before we fully committed to Mongo. Quick side note here about indexes. I'm going to talk more about indexes later on, but I wanted to mention them here. We consciously used no indexes up front and added them on later on as needed. We did that in part because we didn't know which ones are going to work and which ones wouldn't, and in part because we wanted to prove to ourselves that everything will scale. So much for our considerations and proof of concept. I'm not going to bore you with all the challenges and victories that come with delivering a new platform, but let me show you what we ended up with. Here's our collection service, which is a bunch of AWS lambdas that are kicked off of a Kinesis stream, the Kinesis being the AWS real-time streaming platform. These are bursty high writes. This service and all the ones you guys are about to see are all written in Node.js. Here's our enrichment service, which is a Dockerized auto-scaling group. For the ones of you who use AWS, this is Elastic Beanstalk. These are our complex, constant, complex reads and simple updates. Same access pattern. The management service allows a user to log in and enrich content manually. And last but not least, our display service, which is obviously constant high reads and another auto-scaling group. What is powering all that? You guessed it. It's a convoluted combination of Cassandra, Elasticsearch, MySQL, and whatever the hell else we could find to throw on there. The end. Just joking, of course. All of those conferences turned me down, so we went with Mongo instead, thank God. Here's our new platform, and it comes with a price tag of $6,500 a month. If you guys will remember from my previous slide, our old platform cost $60,000, so this is an almost 90% reduction in cost. Massive cost savings, huge performance gains, strong consistency in a handful of services rather than hundreds of clusters. Great stuff, not without its issues. I'll get to those later. I think it's worth pointing out here that this whole platform is completely serverless or containerized. We have a few lambdas there, and then we have some Dockerized auto-scaling services. And I will speak more about Atlas later, but in terms of its place here, it's a great fit in this architecture where really all we want to do is focus on developing our great product and not worry about infrastructure. How did we come to use Atlas? We didn't start off with it. In our first iteration, we provisioned everything by hand. We had a replica set of some memory-optimized instances. It was cheap. It wasn't super easy to set up, and it wasn't going to be viable long-term. We actually had a similarly set up cluster in production running a side job on our old platform. We never saw any issues with it, but again, we weren't going to risk it this time. The second iteration, we went with Cloud Manager, which is still an option I would definitely recommend to people on a budget. It's cheap, it's fast to set up, it scales with the push of a button. A few issues that we saw, I think, were unique to our setup, but they had to do with our VPCs within AWS. Cloud Manager didn't have a seamless integration at the time. However, for the most part, it allowed us to move fast and not worry about our database. So again, totally reasonable option. We tried Atlas because we wanted more insights into our long-running queries, database operations, things like that, and we have not looked back. What is so great about it? Now, while it's not as cheap as the previous two options, it's way cheaper than having a dedicated DevOps engineers. It's very fast to set up. It could be set up to scale automatically. Push button upgrades and scaling. I think somebody mentioned that at the keynote. This used to be a production situation every time you needed to upgrade your database, and with Atlas you really don't. And of course, it has the insights into our indexes, long-running queries, performance glitches, and so on. I know a lot of the cool things that it does can be done by hand, but I really think unless this is your full-time job, you're just not going to do it, and you're not going to do it as well. It's great, and really, and especially for things like hardware load and database load and hardware operations, Atlas just kills it. To kind of go back to the previous slide, between Atlas and the serverless architecture that we have, our infrastructure really just manages itself, and it leaves our hands free to do what we want to do. I said I'll talk about indexes. We started from 0, and we kind of wanted to see what works and what doesn't. We found that if you can reduce your scan size to thousands of documents, it strikes the right balance between performance gain and cost. Obviously, I can create an index that's going to get me down to a single document, but the cost of doing that is just not worth it. Once we started adding indexes, we went with our best guesses on what would work. Sometimes we were right, sometimes we weren't. For something like display, we knew what was going to be in the query. We have a client name, a timestamp, tags, so that's easy. For some of the more complex queries, like our complex rules, again, we ballparked it. We weren't always right. A big part of our team's philosophy is to do what makes sense at the time and just build stuff that's easy to iterate on. And that's true for our indexes as well. Once we started using Atlas, we realized we weren't using some of our indexes nearly as often as we thought we would be, and so we were able to make informed decisions on which ones to kill. An index killed is as valuable as an index added. Why? Because you want all of your indexes to fit into memory, so if you have a bad one pushing out the good one, obviously that works against that goal. Switching gears a little bit next, I said I'm going to talk about problems. Everything was great for the most part, but you never get something for nothing. Issues come up. This first one had to do with a random day when our database just started failing over inexplicably again and again. During failover, it would be unresponsive for minutes at a time, and the pattern would just repeat itself every hour or so. How did we diagnose it? Board metrics indicated high response times. And further digging indicated that at the time of failover, we had about 30,000 open database connections. So if you're taking notes, what does it take to bring down the primary? In our case, it was about 30,000 open connections. And the solution, we realized that every time we were performing a database operation, we were opening a new connection to the database, and they weren't being closed fast enough. So we switched using connection pools that fixed our problem. The lesson, failover is not cheap and it's not seamless. It's great that it's there, but it's better if it doesn't happen, especially if it was your code that caused it. Next problem, this one happened in the very early stages of our new platform launch. So shortly after our first client went live, we realized that some of their displays were taking more than 6 seconds to load. How did we diagnose it, or how did we detect it? Board metrics indicated high queries taking over 5 seconds. Now, what's curious about this one is that at the same time, Atlas was telling us that database queries were taking less than 100 milliseconds for the same query. So what gives? Turns out the discrepancy was due to the time our Lambda was taking to connect to Mongo. So at the time we were using Lambdas for display, and on cold start, a Lambda would take about 5 seconds to connect to Mongo. Then the actual operation would take less than 100 milliseconds, and the whole thing would get wrapped together in a single metric and get sent to Datadog. The solution was to switch from Lambdas to the Dockerized service that you guys saw earlier. The lesson, don't use Lambdas for constant load. I think that's actually pretty well documented by now. It wasn't so at the time. And also, metrics can sometimes be misleading. It's good to keep in mind to not always take at face value. Next problem, this one has to do with our complex rules. So just to iterate one more time what our rules are. So they're filter followed or filter coupled with an action. So you have a filter that says something like take all content from Twitter that mentions this person, and the action would be request author permission. So as our rules grew in complexity, they started taking, for all of them to run, they started taking more than 30 minutes sometimes. In single database operations, were taking minutes to complete, despite multiple complex indexes that we had. How did we detect it? Atlas board metrics indicated poor rule execution time. And the solution was, we realized that rules were performing actions on matching content, but unmatched content was still being scanned in subsequent executions. And our solution was to exclude scanning of previously unmatched content. I think this one is kind of harder to wrap your head around if you weren't there with us. So just to illustrate, imagine if you have 10,000 documents and 100 of them are red. So you have a filter that's searching for all the red documents. The first time it runs, it's going to find those 100 documents. It's going to mark them as visited, and it's not going to visit them again. But the other 9,900 documents are going to get scanned again and again by this filter that's looking for a red document, even though it's never going to be there. So our solution was to include a timestamp in our query that would only search content that has changed since the last time the rule ran. So if something is yellow and it could have turned red in the last time the rule ran, then great, we'll go and search for it. Otherwise, we wouldn't. The lesson, don't rescan if you don't have to, and don't let your database do all of your work for you. I think this one is a great example of somewhere where somebody can say, my database isn't scaling, it's not able to perform complex queries in real time, it doesn't work. Fix your code, right? The hardware is great, tools are great, but they can only carry you so far. I think sometimes we tend to get sloppier with how we write our code because of how cheap and how easy hardware is, but we have to write code responsibly too. And speaking of bad code, this last problem, I promise, had to do with a time when some bad code caused major data corruption across all of our clients, millions and millions of documents. How did we detect it? We didn't need board metrics for this one because client complaints started pouring in. And the solution was an Atlas point-in-time recovery. We rolled back to about 12 hours ago since our last backup. And then we cherry-picked client enrichment actions that have happened since the corruption happened. Aggregations proved very helpful in cross-referencing what has changed when. Very bad day. It happened on a Friday. I think these things always happen on a Friday. You know, have like a happy hour and a boondoggle planned, and instead you get to deal with that. Somehow Atlas made it, very easy and pain-free to deal with, considering. The lesson: keep audits and have a solid recovery plan. Before this happened, we kept saying we need to do a dry run on recovery from backup, and we just never did it. I'm sure there's people in the audience thinking the same thing. I strongly encourage you to do it. You don't want it to be the first time when it's a production escalation. Enough of past problems, future problems that I anticipate to see: scale, size, and cost. Obviously, how we will address. I think a lot of people store or keep a lot more data than they think they need, so I think this would be a good time for us to reevaluate and clean up. I think in our case, partial indexes are going to prove very useful. For better or worse, nobody cares what somebody posted on Instagram 2 years ago. So I think partially indexing on a timestamp would be an easy way to gain some performance there and cost. Some nice side effects that came from being nice and unexpected side effects that came from us being our own DBA. We were able to give our services team a read-only view into our database. So they're able to get a lot more insight into our data than the actual application provides. Also because of how simple the Mongo schema is and how similar to the business model is, it's very easy for the services team to query objects and to know exactly what they're looking for. According to our product manager, since the switch, we've had about an 80% reduction in tickets, and I think this read-only view is in big part responsible for that. Next one, I think we became an accidental test case for other teams in the company that are considering going the hosted route. It's much easier to walk a beaten path and and it's good to have all these positive examples to speak of next time somebody mentions scale. This last one, specifically to do with Atlas, I can't stress this one enough. I expected us to have to do some maintenance. We haven't had to do any. It's harder to put a cost on something like that. We can say that our hosting costs went from 60,000 to 6,000, but it's harder to gauge how much time and money we've actually saved by not having to worry about our database. As the old commercial goes, old platform, 60,000, new platform, 6,000, getting to focus all my time on development, priceless. It is. A few things I wanted to mention that I didn't think fit on any of the other slides. The text index, it didn't really work for us. It's huge. It didn't always behave predictably, and it can be compounded, which was important for us since we're running a multi-tenant platform. So what we actually do is try to narrow down our searches and then use a regular expression to search for text, and it seems to work well for us. Hint is great. Even when you think that Mongo will pick the right index to use, it sometimes doesn't. So if you can add hint to your code, by all means do it. And for some reason, it doesn't work with updates. I don't know why, but I'm here in an official capacity. So Mongo, if you're listening, please fix it. It would help me out a lot. Final thoughts. Bottlenecks happen, services break, requirements change, products evolve. What makes a good data store is not infallibility, but the tools and the ability to detect issues fast, diagnose, develop fast, and recover. What makes a great data store, and really I think any great tool, is the ability to, is that it allows you to be agile and to iterate, and to work on what you're passionate about, which in our case is build a great product. Thank you to my team, Seb, Kenny, Frank, Paul. None of that would have happened without those guys. So much thought and so much effort went into this platform and continues to go into it. Praveen, my manager and counterpart at the time, he actually listened to a dry run of this talk and laughed at my jokes, unlike most of you guys. And finally, thank you all so much for being here. Such a great conference, so many great talks going on. I'm really honored that you guys chose mine. I hope you got some value out of it. I certainly love sharing it with you guys. Thank you. Questions? You'll have a microphone coming to you.
Hi, my name is Fan. I'm from the Zimbox in Mountain View. Okay, thanks so much for the presentation. Okay, I think we experienced more issues than you guys experienced, right? And also one question, how much data you stored with Mongo? And how could you rebuild the index at a later stage? Because for us, it takes for 6 hours and longer to build a new index. And also another second question, how to do the delete data and restore data when necessary? Because also it's very, very difficult for us to do that. We spend 4 days to remove some old data.
So the question was, how much data do we have in Mongo, and how long does indexing and deletion take? We have, so last time I checked was a few days ago, we had, I think, 46 million documents in our bigger collection, about 46 million and counting. I can't tell you exactly how long an index takes. It's in the order of a couple hours or so. You know, usually when we are adding one, we would run it in the background, and you know, when it completes, it completes. It doesn't really hose up anything. So we haven't seen any issues with that. But yeah, I assume based on what you're saying, you probably have a larger.
46 million, right?
Yes.
Yeah, it's less than 1% of our data. So I think that's the difference, right?
Yeah, I'm certain that it does.
I think with 100 million, it should be really easy for us to deal with. That 100 million racks for one connection is really easy to deal. And for I think 1 billion is very difficult. And when you reach 10 billion, it's very
I could imagine that with content growth, there will be other challenges that hopefully I think Atlas is in Mongo in general is well tooled to address. But I haven't been where you are, so we'll see. We're still waiting on that. There was another question over there in the.
About sharding, did you consider sharding? Did your examination of your utilization patterns steer you away from that?
Yeah, so I'll repeat the question. This is being recorded, so no, it's great, but they want.
I can say it again. Did you consider sharding, or did your consideration of utilization patterns steer you away from that?
Yes, so sharding, no, we haven't considered it yet. And going back a little bit to the previous slide where I spoke about iteration and doing what makes sense at the time, I do feel like a lot of things tend to get over-engineered when, and things and stuff like sharding is being used before it's really necessary. I wouldn't say we haven't considered it. We've obviously talked about it, but we haven't seen a use case for sharding, so we're not there yet, or I don't know if we will be. Other questions?
What kind of security model you have it on the system?
So we use Atlas, so we have so the cluster itself is paired with our VPC within Amazon, and we access it that way, and we have. I'm sorry, I didn't repeat the question. There's also a few over there. Sorry.
Is it hosted on cloud or on-premise? The MongoDB you use on this?
It's hosted by Atlas, or it's hosted by Mongo, and it's paired with a cloud solution that or with our AWS cloud.
On the AWS cloud. What's the procedure to migrate the data from your site, whatever this legacy data, into the MongoDB? Is there any specific tool used, or use MongoDB tool?
So the question was about how do we migrate data between AWS and Atlas?
Legacy model, whatever you had before, to the.
I see what you're asking. So our migration between our SQL/Cassandra solution and Mongo, we ran a script that would extract. We ran an ETL script that would extract, the data that was in Cassandra and store it in Mongo. It was a one-time script that we ran to, migrate. And again, because of the peering, it was seamless between our current hosted solution and the RDS instances that we had before.
Can I add to that one? I think I was in one of the sessions in the morning, Cisco session, I think they developed this tool basically, and they put it in the GitHub for everyone. Basically, it can look at any RDBMS, and what they are claiming, any RDBMS, they can just convert everything and show it in the collection format. And you can choose whether it's correct or not, then deploy it into MongoDB. So you might want to look at that GitHub thing.
I actually have seen the Cisco solution myself. I remember seeing a workshop somewhere for it.
Hey, great presentation. Thank you for sharing your experience. You were talking about text indexes not being that great. Have you tried to play with Elastic, maybe seeding that data into Elastic? And is that a consideration? Because we've had the same experience, and we kind of didn't. We just did a POC with it, and it seems to work like 20,000 times faster.
Are you saying that you're now using Elasticsearch on top of Mongo?
Yeah, just for text.
I see. Yeah. So the question was, have we considered indexing our Mongo and not using the Mongo text index? We, again, like with Sharding, we've talked about it because of how well it worked for us to just narrow down our search size. We didn't really explore that path. We don't do very complex search. Some of the fancier Elasticsearch options out there we've never really utilized. So I do think that probably is a good use case. I would love to actually hear more about that one. I haven't personally tried it, no.
What are the specific issues with your update issues you mentioned?
Update issues.
You said it's not so great yet. That's what one of the slides said. Text index and then updates, like oftentimes.
Oh, I see. I'm sorry, I misunderstood your question. Yeah, so yeah, those were kind of separate bullet points. There's the text index, and then there's the update. And specifically with the update, I was talking about hint. If you have a query where you're updating a document rather than just doing a find, you can't use hint in the Mongo console or in any of the drivers, so you can't tell it, hey, when you're updating and searching for documents, use this specific index. So that's kind of the issue. So sometimes you would have an update operation that instead of using the index that you expected to, would use one that is slower and not doing as well.
I'm curious. You said that your company, at least the DevOps partners, were like Cassandra better than MongoDB, but I don't remember if you told us why that you chose that over Cassandra.
Yeah. So the question was, why did we choose Mongo over Cassandra? And usually my answer to this question is, if Cassandra works for you, great. For us, because of the issues that we saw in our old platform, we had it was expensive to run. It wasn't performing as fast as we were hoping to. I think also the leads with Cassandra to me seem like a nightmare. You run into tombstone issues and just other things that didn't make it super usable. The bigger answer really is, we had many people on the team who had previous positive experience with Mongo. We thought it would work well for us, and it has proven to so far. Definitely less work to maintain and manage than Cassandra ever was. Anyone else? Great. All right. Thank you again so much for coming.